Welcome to this video. In this video we are going to discuss the introduction of assembler. So what is an assembler? Assembler is a program for converting instructions written in low-level assembly code into machine code, relocatable machine code, and generating along information for the loader. So this is the definition of assembler. Assembler is a program for converting instructions written in low-level assembly code into relocatable machine code and generating along information for the loader. So this diagram shows the concept of assembler. Okay, so this assembler program, it takes the input, so that is the assembly code program. So after the assembler receives the assembly code, the program, it converts this assembly code program into machine code programs. Okay, so this is the main function of an assembler. Here you can say it generates the instructions by evaluating the mnemonics. Mnemonics means symbols in operation field, and find the value of the symbol and literals to produce a machine code. So this is a function of the assembly language program. Okay, so the assembly language program, the assembler program that generates the instructions by evaluating the input program. So that is written in mnemonic, that means pseudo codes. So that contains a mnemonic in operation field and find the value of the symbol and literals to produce the machine code. So now if an assembler do all this work in one scan, then it is called as a single pass assembler. Otherwise, if it does in multiple scans, means then it is called as a multiple pass assembler. So these are the two types of assemblers. Okay, if an assembler do all this work means it generates instructions by evaluating the mnemonics in operation field and find the value of symbol and literals to produce a machine code. So these all operations are performed by the assembler in one scan, which that is called as a single pass assembler. If it does these all tasks in multiple scans, means then it is called as a multiple pass assembler. Here assembler divides these tasks into two passes. Okay, pass 1 and pass 2. So all these operations are performed in two phases. Okay, so that is first phase is called as a pass 1, second phase is called as pass 2. So what are the various operations are performed in the first phase, means is pass 1. So the first thing is define symbols and literals and remember them in the symbol table and literal table respectively. Okay, we have a symbol table and literal table. So all the symbols and literals used in the program, so they all are defined. Okay, defined in the corresponding symbol table and literal table. Second thing is keep track of location counter. Okay, LC. And third thing is process pseudo operations. Okay, so these all tasks are performed in the pass 1. Okay, the next, what are the tasks performed by pass 2 is in the pass 2 generates object code by converting the symbolic opcode into respective numeric opcode. So that is the first operation. Second operation is generate data for literals and look for values of symbols. Okay, so these are the two operations performed in pass 2. Okay, generates object code by converting symbolic opcode into respective numeric code. Second, generate data for literals and look for values of symbols. Okay, so these are the various operations performed by pass 1 and pass 2. Okay, so here we are discussing a small assembly language program. Okay, to understand the program, understanding the program, so first we have to know about the general format of assembly language statement. Okay, so what is the format of assembly language statement is, it contains three parts. Okay, first part is a label, second part is a opcode, third part is an operand. Okay, so here is a one example of an assembly language statement. Okay, m add r1 comma equal to 3. Okay, so here M means is a label. Okay, M means label. So add is a symbolic opcode. Then R1 is a address. Okay, register. Okay, symbolic register operand. Then tree is a literal. Okay, M is a label. Add is a symbolic opcode. R1 is a symbolic register operand. Okay, R1 is a operand. Tree is a literal. Okay, so this is an example of an assembly language statement. Next, let us see a simple assembly program. Okay, so the assembly program is in this format we have to write. Okay, so first one is label, second one output, third one operand, and fourth one it is LC, the allocation counter value. So here, if you have a label, means you want to write in this place. Okay, all the outputs are next we have to write. Then you have to write the operand like that. Okay. Next, let us see about the explanation of this program. Okay. So in this program, the first statement is a start statement. Okay. Start statement. So this instruction starts the execution of a program from location 200, and label with the start provides name for the program. Okay, the name for the program. So here, what is the label? John. John is the name of the program. Okay, so and also here we have the location 200. So the program instructions starts the execution of the program from the location 200. Okay, so that will be given in this first line. Okay, start John is the label, name of the program, start 200. Okay, 200 it is the where the execution starts. Okay, so that that is 200. The 200 address space 200 the program execution starts. Okay, from the location 200. Okay, the next one it is move R. Okay, move R means it moves the content of the literal. Okay, so here we have move R, R1 equal to 3 200. So R1 it is the, what is R1? Symbolic register. Okay, symbolic register. Then 3 is the literal. Okay, so move R, it moves the content of literal 3 into the register operand R1. Okay, R1 is the register. So now we have to move the literal, the constant value 3 to the register R1. Okay, the next one it is move M. It moves the content of the register into the main memory operand X. Okay, in the memory fourth statement memory M equal to X, R1 comma X. Okay, so it's a memory variable. Okay, X is a memory variable. The value of that memory variable is moved to the register R1. Okay, the content is value of the content of the register is moved to the memory operand X. Okay, so already in the register R1 we have the constant value 3. So now that value is moved to the memory variable X. Okay, this. The next one is move R. It again move the content of the literal 2 into the register operand R2, and its label is specified as L1. Okay, so that is here. Okay, the literal value 2 is moved to the register. Okay, R2. The next L2ORG, it assigns the address to literals. Okay, the next one is DS data space. It assigns a data space of 1 to symbol X. Then last statement is end. Okay, it finishes the program execution. So this statement, it indicates the program execution. The program execution will finish. Okay, so it finishes the program execution. Okay. Next, what are the various functions? Okay, functions are there in the pass 1 and pass 2. Next, we can see. Okay, working on pass 1. Already I told you in the pass 1. The main operation is define the symbol and literal table with their addresses. Okay, So here in the step 1 we have the statement start 200. Okay, here we have no symbol or literal, so the both table would be empty. Okay, the step 2 we have a statement move r1 equal to 3 200. Okay, here what is the literal 3? So in the literal table is created. Okay, and the value 3 is stored in the literal table. We have the two parts, okay, literal and address. Literal part, the literal constant value 3 is stored in the literal part. Okay, so this is happened when the step 2 move r1 equal to 3 200. So that statement is executed. This was created. Okay, then step 3 we have move m r1 comma x to point 1. So here x is a symbol, right? X is a symbol or variable referred to prior to its declaration, so it is stored in the symbol table with the blank address field. Okay, the symbol, now the symbol table is created. The symbol x is stored in the symbol table. Next, step 4 L1 move r2 equal to 2.202. So L1 is a label and equal to 2 is a literal. So to store them in a respective symbol table and literal table are updated now. Okay. The next, here the address of the literal. Okay, so that is specified now. Okay, the literal 3. What is the value? What is the address? 203 is stored. Okay, then here also the symbol, the address of the symbols, both the x and L1, the addresses are assigned. Okay, so here program the end 2.5 when they executed, the program finishes execution. Remaining literal will get addresses specified by LC value and end instruction. Okay, so here's the complete symbol table and literal table made by pass on of the assembler. Okay, now all the values are entered into the symbol table and literal table. Okay, and after the pass to operation is performed, here pass to uses some data bases. Okay, MOT table, machine opcode table, pseudo opcode table, storing value of base registers, that is base table. The next one is location counter LC. Okay, so appropriate details are stored in all the tables. Okay, so pass to assembler generates a machine code by converting the symbolic machine code into their respective bit configuration, that means machine understandable form. It stores all the machine opcode in MOT table. Okay, so machine opcode table with the symbolic code, their length and their bit configurations. It will also process pseudo opcodes and will store them in the POT, pseudo operational table. So this is the various functions of the assemblers. Okay, when the assembler converts the assembly language program into machine language program by using these two passes. Okay, so this is all about the basic informations of assembler. Thank you.